Hi everyone, in this video we are going to create a simple lab where we'll create these two computer networks. So you can see one computer network in green in color, and then we have some other color on the right hand side. So these two computers networks will be connected using two routers, and we will use ospf routing protocols to configure or to enable routing protocols on these two routers. So let's begin from the start. So to create first computer network, we are selecting maybe three PCs here. So we have these three computers here. And now to create a local area network of these three computers, we need a switch. So I'm selecting a switch here. And then let's say we are creating another computer lab or simple computer network, a different subnet. So we have selecting switch, and then in addition to those switch we have these three PCs here as well. You can see we have these three PCs there, and then we need to connect these PCs to those switches. So let's say we are connecting those PCs using not automatic, but if just for explanation that these are two different devices. If these are two different devices, then we use copper straight through cable. So this is a copper straight through cable, this is a right cable which we need for connection between this computer and the switch. And on this computer we have a port that is fast Ethernet 0 port. So on the computer we selected with the fast Ethernet 0 port, and on the switch we have these all ports, and at the moment we can select any of these fast Ethernet ports. So I'm selecting fast Ethernet 0/1 port. First computer is connected with the switch, and in the same way we can select the second computer. So connect the second computer using fast Ethernet port, and on the switch we use fast Ethernet 0/2. And now I'm just going to press the control key on my keyboard, and then I can use this connection fast Ethernet to the switch. So now I don't need to select again and again the cable. I have just already selected once, and now when I have already pressed this control key on my keyboard, I'm going to connect all these computers with the switch. You can see now all these computers are connected with these switches. So now we have these two computer labs, and maybe just to make it a clean, just to give it a clean look like this one, we can do this thing. Okay, now these two computers, we say that one of the computers or the one computer network is in 192.168.10.0 network, and let's say other computer network is in 172 dot, so we have 172.16.0 and dot 0, maybe 16 if we use 16 bits in the subnet mask and the subnet portion. So here we will be using 24 bits in the subnet mask. So we have this network, these different network, two switches. Now we can assign IP addresses to these PCs, but these all PCs should have the network portion exactly same. So for example, if we go the first computer, so IP address for the first computer will be 192.168.10, and the last octet is representing the host portion. So for that we say 1. And now this is subnet mask for the first computer. And now if we go to second computer, 192.168.10, so this is the network portion. This will be same for all, but the host portion, this should be different. So now we have using .2. And the same way for the third computer, if you go to IP address, we have 192.168.10. The host portion will be different, so let's say use 3, and this is 255.255. It means this is 24 bits subnet mask. So now these computers are connected with each other, and if we assign the IP address to computers on this side, so now if we go again to this computer, and now we use this this IP address. So the first computer, and then this should be 172.16.0.1, and then this is a subnet mask. In the same way for the second computer, we go and click this one, so that should be 172.16.0.2, and then this is 172.16.0.3, and this is the subnet mask. So now these three computers have been assigned an IP address. Now specifically, if I color them, then this would look better. If I color the first computer network like this one, so this is my first computer network, and if I give it a different color for the next one, so maybe we can have any color like this one. So we have, this is the second computer network. So now we have colored these two computer networks. This first computer network, second computer network, we are different in different subnets. Now let's check their connectivity. If we can ping from PC 0 to PC 2, so for that we can use, for example, we go to this computer and this computer and go to command prompt, and if we want to ping, then maybe PC2 maybe. So for that 192.168.10.3, so IP address 192.168.10 is same, only this is 1 and this .2.3. So I'm going to ping .3 computer, and you can see we are getting reply. It means these computers are connected. And the same way we can verify this computer network on the right hand side, and this time instead of using ping command, I can go to simulation mode here on the right hand side. You can see this window appears here, and now if I click this edit filter, so now in this case it will be displaying different PDUs, but I want to see only the ICMP traffic, so I can just click show none or show all. So show all means all and show none means only. It will not show anything, but we want to show that we want to see the traffic of ICMP. So I just click ICMP and close it. And now from at this point I can just select this simple PDU. So I want to check the connectivity from PC3 to PC5. So I just clicked it on both of the nodes. And now if I go and I click on this capture and forward button, which is on the left hand side, not left, sorry, right hand side. So if I click this one, so now if you see, click again. So if you see that this goes there, and then it goes to PC5. PC5 gives response back, and then finally we get a reply back, and you can see on the bottom right, you can see this shows that this is successful. So source PC3, destination PC5, ICMP traffic type, so that's successful. It means those PCs are also able to ping each other, they are reachable. Now if we use, for instance, for connectivity, let's say we can use a single router here and we can connect these two networks using this single router. But let's say I'm using two routers, one router is there and the second router for this network, and then we will make the connectivity between these two routers, just for illustrations to look at the routing protocol. Anyway, so now we are connecting this switch with the router. So switch and router, these are two different devices, so we can use we need to use this copper straight through cables. Again, I'm using copper straight through cable, and on this switch I'm selecting gigabit Ethernet 0/1, and on the router I'm selecting gigabit Ethernet 0/0/1 for this interface, the giga and giga on both of the ends. In the same way, if we connect this switch with the router, so again gigabit 0/1 and then giga 0/0/1. So we can use, we can use any port here. We have 2 gig ports on this router, 2 gig ports on this router. We can use any port, but I just making 0 and 1, and so 0/0 I can connect with, I'll be using console just to show you. Let's make connection. So these router and router, these are similar devices, and for connecting similar devices we need to use copper crossover. So we are using crossover cable here, and from this you see gigabit ethernet 0/0 on the first router, and on this router as well I did not use gigabit 0/0/0 before. So now it means now these both of the ports are connected using gigabit 0/0/0 port. So just to make consistency between the connection, otherwise I could have used any port there. So now these two computers are connected using routers, and now if we try to ping from this PC to this PC, this will not work. Even we can try, for example, this PC has got IP address of 172.16.0.3. So if I go to PC0 and if I go to command prompt and I say ping 172.16.0.3, so it will not work because these routers are not configured to forward the traffic from one network to another. So this will not work and this would fail, but we can wait for the response. So actually, sorry, we are in the simulation mode, is taking time, but if we go to real-time mode and again use the same command, so you see request timeout, and it will go the second time again, it will check for the connectivity and it will try 4 times at least for checking the connectivity. So you can see these computers are not able to reach each other because they are in different networks. And now if they are in different networks, then we need a device which can route the packet from this network to the second network. So for that we need a network device, a networking device, and router is working at the network layer. But now for working we need to configure these routers. So first we need to configure this interface. So if I color it like this one, if we have select this color, so we need to configure this interface of the router on this router, and also we need to configure this interface. You see interface in red in color, and this interface is actually connected with this network and on this router. So let's see, maybe if I give them names, so this is router 1, and if I say this is router 2, this would be easy to call them with the names. So now we have R1 and R2. So on R1 we have this interface, that gigabit 0/0/1. We need to assign an IP address, but remember now this interface needs to be in this network, and then this interface will act as a default gateway for these all computers. In that case, if any of these computers wanted to send something to different network or to this network on the right hand side, that packet will be sent to the default gateway. So this interface of this router will be used as a default gateway, and the default gateway should have an IP address which should be exactly on the same network. So 192.168.10, this portion will be same for this interface as well. So exactly in the same way, this interface for router R2, so that interface should be like 172.16.0, and then in the host portion we can use any number except we already used for these PCs. So it means this should be in this network. So, and then we can configure it. And one more thing, for connection from this routers to this router, so connection in between these two routers, again we also need a different subnets for the connectivity from this router. So I'm going to color it for illustration. So this connectivity, or these two interfaces, also need an IP address, and those two IP addresses should also be within the same subnet. And for that, for instance, we will be using, so let me close it. So for that we will be using, let's say 10.20.30.0 and /30. So this is the IP address we will be using. So in this, if you remember that in this network, by using this variable length subnet mask, we can only have 4 IP addresses and only 2 IP addresses will be usable IP addresses. So that is VLSM. variable length subnet masking, and I'm going to put a link for understanding of VLSM as well in the description section. So anyway, so this is the subnet we will be using. So now we can configure this router. So I'm going to router 1, and this is the command line interface. We are at the moment in the user mode, and for configuration of interface we need to go to the global configuration mode, and for that first we need to go to privilege mode, and from privilege mode, so enable command puts us just gives us the privilege mode, and from privilege mode we can use the config t command or configure terminal command to go to global configuration mode. And once we are in global configuration mode, we can go to individual interfaces of the router. So the first interface which I'm going, that is gigabit 0/0/1. So just I'm writing few letters of the command and then pressing the tab key. In that way the packet tracer is going to complete that command for me. So interface gigabit ethernet 0/0/1. This is the interface I am going now. So now you can see we are in that interface mode, and now we need to give an IP address. So this is this interface which is in red in color for router 1. So for this interface we need to have an IP address which is in this subnet, so that would be 192.168.10, and the host portion, let's say .10. So this is the IP address, and then we need to give subnet mask, so that will be 255.255.255.0. Press enter. Okay, we missed the command itself, the keyword, sorry for that. So this is IP address, and then this is the IP address which we want to configure. So now this is a complete command, and press enter. And now we need to assign, or we need to give a command which will activate this interface to send and receive the packet. So that is no shutdown command. And when we press shutdown, no shutdown command, it says that line protocol is up on interface. So, and you can see now it says that this interface is ready to send and receive the packets. And as soon as we assign, we give this command, you can see this color will turn to green color after some time. So after exchanging some messages, they'll find each other, and this will turn into green color. So in the same way, we have to configure this interface. You can see this is already in green color now. So in the same way, we have to configure this interface of router R2. So I'm going to router R2, and now we go to privilege mode using enable command. So instead of enable complete, I just wrote en, and package tracer found that this is the enable command. And from enable command, again we need to go to global configuration mode, and for that I'm using config t instead of complete configure terminal command. Config t, and now I need to go to this interface of router 2. So this is the router 2, and on router 2 we have gigabit 0/0/1 interface. I'm going to say interface gig and press tab, and then 0/0/1 interface, press enter. So when you are in the interface mode and we need to assign an IP address, for that I'm going to use IP address command, and then we have to give IP address in this subnet, so that is 172.16.0. So 172.16.0, and in the host portion, let's say we use .10, and then still we need to give a subnet mask. So that will be 255.255.0.0. So we have used 16/16 as subnet mask. So for that we assign the subnet mask, and now finally the command is no shut to activate this interface to transmit and receive the packets on that particular interface. And now this log message actually confirms this activity, that now this interface is basically active. It will transmit and receive the commands. That's done, and press enter. Now these all three computers are able to send all the data which needs to go to somewhere else to this interface that will act as a default gateway for these computers. And after some time this interface will also turn into green. So you can see now this is green. That means now up to this point they are connected. Now, for example, if we want to see the connectivity, then we can go to simulation mode, and this would be good to see. We can also use the ping command, but we want to see the movement of this PDU. So we want to ping from this computer to this interface. So it means just to this one, maybe not interface, but if we go to this PC5, let's see what happens. Now this says this is not reachable because we have not configured, or we have not connected these. We have connected, but there is no routing information in between those two router. So they are not, so this router is not able to reach this network, which is basically 172.16.0.0. But let's say if we just delete this one, and if I use the same PDU from this PC to this router's interface, and if I use this capture and forward button on the right hand side, see this goes to switch forwards to that interface of the router, and then that interface comes back. The message comes back from that interface, and you can see on the right hand side, bottom right, you can see this says that this is successful from PC 0 to destination router 0, which is this is router 0. This is router. Okay, so we saw that this computer from this network was not able to reach this network. So now what we need to do, we need to enable routing. We can also configure a static routing, but for just demonstration of ospf, I'm going to enable ospf routing on these all interfaces. But before that, let's see what is in the routing table of these routers. So as we know that routers maintains a routing table, and by using those routing table, they actually make the decisions for the packets which they receive. So for example, when they receive some packets here, so once is this one, is it this one. So when they receive this packet, like packet goes to router, and a router has to make decisions that where to forward this packet. Okay, so for that we need a routing protocol. So I'm going to configure routing protocol. We can also do a static, but I'm going to configure the routing protocol, that is ospf. And for that I'm just using simple command. So for every interface, yeah, before that we can see maybe if we have some routing table entries there. So for that we are in the privilege mode, and if this in the privilege mode, we can use show IP route command to see what routes are available in the routing table of this router. So we can see in this router we have 192.168.10.0. We have the information about this one, and yes, only this network which is directly connected with this one. And let's see on this router. So also we have not assigned the IP addresses to these interfaces as well. So these interfaces, again, let's get help from this let's get help from these colors here. Sorry, we also have not assigned an IP address to these interfaces. So before yes, so before enabling this, before enabling any routing protocol, we also need to give an IP address to this one. So for that I'm going to use this one. Yes, this is the one, and here also this is the interface we'll be using. Okay, so for those interfaces we need to assign IP addresses. So I'm going to this computer, and let's say interface. First we need to go to global configuration mode using config T, and then interface. And if you remember, this interface was G, so I can use just G instead of gigabit Ethernet 0/0/0/0 G 0/0/0. Press enter, and now we can give IP address. So in this interface, for this interface we will be using this subnet. So I'm using that IP address, so that will be like 10.20.30.1, and then subnet mask will be 255.255.255.252, and press enter, and then no shutdown command to activate this interface. We are done with this interface. And now let's say go to this interface, and here we say interface gigabit 0/0/0 and press enter. IP address, that will be IP address will be there from this one 10.20.30. We can say 10.20.30.2, and the subnet mask is 255.255.255.252, and no shutdown. Okay, and again we can use this. Still this packet can't reach this one, they can't reach, so we can try this one again. If we go to this PDU and click on PC0, and if I click on PC5, and let's see what happens. So you can see this is not reachable, so this says that this not, and we can see on the bottom right hand side that this failed, we can't send it, or the message was not delivered, connection failed. Now let's see, now if we see the routing table on this router, so Control Z command, I'm in the privilege mode, I can use show IP route command to see the routing table entries for router R1. You can see in the router R1 we have the entry for network 10.0.0. This variable is subnetted, so that is this interface of the router, which is connected with another router, and then we also have this 10.20.30. so this is the exactly the interface which this is connected, and this is the network. And then we have the second interface of the router, that's 192.168.10.10. so the second interface is this one. So if I say just see, if I mention, so on this router you can see we have like we have this interface, and we got this interface, so both of the interfaces information is there. And now if we go to this router, that's router R2, and if we see the routing table, so we can say that Control Z, we are in the privilege mode, and then we say show IP route, and this will display the routing table entries. Now at that moment this is 10.20.30 and 172.16.0.0. so it means now on this router again we have the information about this interface, that is this interface, and also about this interface. Okay, about this interface. So now these two, maybe if I draw like this one, you can see these two interfaces information is there, but they don't have, like router R1 does not have information about this network which is 172.16, and this router 2 doesn't have information about this 192.6 168.10. they don't have this information. And now for letting these two routers know about each other, we need a routing protocol, and for that we are going to configure ospf routing protocol. So for that we need to go to these individual interfaces of the router. So for example, in the router 1 I'm going to interface gigabit 0/0/0, and here I am using command that is IP ospf, and then a process ID, that's 1, and area number 1. This is the command to enable ospf on that particular interface of the router. And now let's go to the second interface, that is G0/0/1, and on that interface again we are going to enable ospf routing. So ospf process ID 1, area 1, done. So we are done with this router where we enable this ospf routing protocol there. And now in the same way we need to go to router R2. It has got two interfaces, so we go to global configuration mode, and then we go to interface gigabit 0/0/0 and enable ospf routing. So I'm saying IP ospf process ID 1, area 1. So this is the command used to enable ospf routing on that interface. And then second interface is G0/0/1 and press enter. and we need to enable ospf routing. So for that, IP ospf process ID 1 area 1 and press enter. So we have enabled ospf routing on router R1 as well as on router R2. Now they should be able to exchange, so we should be able to send some packets from PC0 to PC5. But first, let's see that if this router R1 has actually learned the routes there. Okay, so maybe we can also see here as well on router R2, we need to go to privilege mode using Control Z. But to move, maybe they are exchanging some information because they need to establish a neighbor relationship with each other. Once they have established a neighbor relationship, only then they will be exchanging the routing information with each other. And we have a video, separate video on ospf routing as well, and the details are there. But now hopefully they might have exchanged that information with each other. And now if we use show IP route command to see the routing table entries there, but it still doesn't show there, it means we need to wait a bit, because C means connected, L means local, and if there is some entry found by ospf, then we should have some O letter here. So maybe for that, if we just play this, if we say this fast forward like, then we can actually move it further. So if we say real time, and if we say move forward, fast forward, and then if we again click this one, you can see we have a message, log message says ospf and process one neighbor. This is neighbor, and this is the interface from which they got the information. You can see that now they are exchanging this ospf information with each other. And now after this, if we use the show IP route command, hopefully we will have an entry for ospf as well. You can see O stands for ospf, and by ospf this router 1 has got information about the network, which is 172.16.0.0. 172.16.0 and 0, this is the network. You can see on the right hand side. So now about this network, the router 1 has got the information. It means now router 1 can forward the packets if any of the computer from its network will forward that. So now router 1 has the information exactly in the same way. If we go to router R2, you can see we got this log message which indicates that ospf information is being exchanged between these two routers. And after this, if we use the show IP route command, this router will also display an entry, the routing table entry, which has been learned by using ospf routing protocol. So you can see this O stands for ospf, and by using that ospf routing protocol, router R1 actually knows the network. He knows about the network, which is 172.168.10.0. So you can see this is the network for which now router R2 has got the information. So now, for example, if PC5, let's go say PC5, I'm going to simulation mode. So now if PC5 wants to reach PC0, so we can use this PDU. I'm going to click PC5 and then PC0. Then if everything works fine, then this PC5 should be able to reach PC0. So for that, I'm going to this capture and forward button and click this one. So we can see that this is, yes, one more thing we have not configured, and that's good. That problem arise and we found a problem. Problem is that we have not configured the default gateway information in these computers. So at the moment, the computer don't know that where to forward the packet if this packet is supposed to go to different network. So in that case, these all computers needs to have information about the default gateway. So I'm going to delete this one at real time. And so if we go here, PC3, go IP address, you can see default gateway information is empty. And in this field, we have to give the default gateway information, which is this interface of the router R2. That will be 172.168.10.0. that will be 16 172.16.0 dot that will be 10. So that's the IP address of this interface, which will be used as the default gateway. And now if we go to second computer, we need to give default gateway 172.16.0.10, and the same way here IP address 172.16.0.10. And for these PCs, PC0 for instance, which will be the, so first we need to go IP configuration. But what IP address we will use for the default gateway? So if you remember, that was this interface of the router, gigabit Ethernet 0/0/1 interface, and the IP address for that we assigned that was 192.168.10.10. And then for this PC as well, 192.168.10.10, and for this PC as well, default gateway information will be 192.168.10.10. Is done. Now invalid gateway for this, let's see what in, so that should be 192.168.10.10. Now hopefully this PC should be able to reach that one. So again, go to simulation mode and we click on PDU PC5 to PC0 and click on capture and forward. So you can see now the PDU moves to switch forwards this to the router receives this back and this by PDU, and you can see here as well, we can, if we want to see some fields there, so we can click there. We can see at the layer 3 what we have. The IP header source address is 172.16.03, so this is the IP address of this PC5, and this is going to destination IP address, destination computer, that is this PC0, and its IP address is 192.168.1 or 10.1. So we can see different inbound PDUs details as well as outbound PDU details by clicking on this one. Anyway, this packet received at the router will make decision, and the router will forward this PDU to the next router. The next router will forward to the switch, and the switch will forward this to all the PCs, and only the intended PC will receive it. Rest of the PCs will reject it, and now intended PC will respond back, and now that response will come back using the same path to router 1 and then router 2, and finally this will be received by PC5. And once they see this one, it means now this confirms that connectivity is there, and we can see the message on the right hand side, bottom right. It says successful from source PC5 to destination PC0. So in this way we prove this one that this is working, and the same way, now in the same way, if